solid. I think that's a solid. All right, so then there's different types of reactions. Synthesis is one product from a multitude of atoms or chemicals or elements or whatever. And that would be, for example, if you have a bunch of baking things and you mix them all together and you make one cake. There was a bunch of stuff and then you made one cake. So the cake weighs more than any one of the things, the flour, the sugar, the eggs. But actually, if you weighed up all that stuff and you weighed the cake, it should weigh the same when you're done, right? Hopefully. So synthesis, if you know what synthesis means, it means making one thing from a lot of things. Conveniently enough. All right. Classifying, we have decomposition, one reactant. So you have one thing breaking down into many things. And here's a log. And we talked about dead squirrels, that when a squirrel gets hit by a car, it starts to weigh less and less as more and more things from the squirrel go away, from ants or birds or fungus or whatever it is that's going to eat the squirrel. So when you have one thing and it's going into multiple things, that is decomposition. And then single replacement is when one usually element breaks up a compound so that the one element is now part of the compound and one of the elements in the compound is left out on their own. For example, here done by Mr. Philip Redkin, iron comes in and knocks copper off the sulfate, and then copper's by itself and iron has a sulfate. So here's the iron, it takes the sulfate away, and now copper's all by itself. All right, and then there's double displacement or double replacement. I keep saying the same, I keep mixing those up, but just know that I can say either one. Here's Daisy and Peach, or Peach and Daisy. Peach and Daisy, I think. All right. Mario and Luigi, and then Mario was with Luigi, now he's with Peach. Luigi was with Mario, now he's with Daisy. So that's double displacement. So they come in pairs and they leave in pairs, but they're not the same. So here you can see calcium leaving with nitrate, it came in with bromine, and silver leaving with bromine, it came in with nitrate. All right, and here's a nice thing here where the silver is taking the chloride from the potassium, and the potassium is taking the nitrate from the silver. Look at that. Thanks, Philip. All right, last one is combustion. And a combustion reaction, you make carbon dioxide and water from some hydrocarbon and oxygen, and this is how we burn things and get our fuel and whatnot. And that's that.
Another kind of reaction is the acid-base reaction. This we'll get into much deeper further on, but just to give this a quick overview. So the Arrhenius theory of acids and bases is going to work just fine for you for most of what you do. He said, this is Savante Arrhenius, that an acid produces H plus in water, which is also known as a proton, and a base will produce OH minus in water. So you see here the H, the leading H, we talked about this when we were talking about compounds along unit 1, that a leading H means it's an acid, and that means H plus is going to come off. It's going to kind of act like a metal. OH being in the compound, OH minus would be released by a base. So real quick, the reason why we say H plus is a proton, because a hydrogen atom is just a proton and an electron. And if it had a +1 charge, that means the electron is gone. And if you don't have an electron anymore, all that's left is a proton. Okay, so bases will react with acids and form water. So this is a lovely thing you can do, and we'll do again later when we do acids and bases. But that's why you can take an antacid and turn an acid into something less toxic. And this is why baking soda and vinegar is so much fun, and it just turns it into salt water. So the acid and the base come together. That H from the HCl and the OH from the base come together and form H2O, right? Two H's and an O. And then the other ions just sort of get together. So that water forms as a liquid. I have it here as HOH because that helps when you're doing some balancing problems with these. Seeing water as HOH, because sometimes you'll see it's coming from an H from one place and an OH in another place. So that's why I did that. But basically, that's H2O. Let's talk about the NaCl now. There's these things called spectator ions, and spectator ions are dissolved ions that stay dissolved after a reaction is done, and these are considered spectator ions. So if I have in a test tube a clear solution of sodium chloride, and that means the sodium and the chloride ions are all broken down and separated. And then I have a clear solution of silver nitrate. So silver and nitrate pulled apart, dissolved by water. But when I put those two clear dissolved solutions together, silver chloride will precipitate at the bottom or somewhere, and then the sodium and the nitrate are still floating around. So we call these nitrates and these sodiums spectators because before the reaction they were all dissolved, and after the reaction they were all dissolved. So they didn't do anything. So here's a video of this occurring. So you see here there's two solutions, sodium chloride aqueous, so completely dissolved, and silver nitrate aqueous, completely dissolved. When you mix this one clear solution, right, completely dissolved, with another one, here comes the drops of the other clear solution, you see that solid forming. So that's the silver chloride forming, but the sodium chloride, sodium nitrate, is still dissolved in water. That's still completely dissolved. So we call those spectator ions.